Okay, this is exam 3 for spring 24. First, for your response, I want to label the types of energy that I have. So here, since I have a velocity and I'm at a certain height, I have both kinetic energy and potential energy. At point B, likewise, kinetic energy and potential energy. Down here at C, H is equal to 0, so I only have kinetic energy. And then up here at D, I'm told a little bit later that it comes to a stop, so V is equal to 0 here, so I only have potential energy. And remembering the conservation of energy, that all of these values have to be the same. So for part A, what types of energy does it have at point B? Well, it has both kinetic and potential because it has a height and it will have a speed. What is the velocity at point C? So I would set the total energy, kinetic plus the potential energy. That's going to be, in this case, at point A, I know the speed and the height at that point is equal to, at point C, I only have kinetic energy, is equal to that. So I can begin to put in those values. 1/2 of m times, that's 2 squared, plus m times g times 8 is equal to 1/2 m v squared. I'm looking for v. The m's cancel out. That's 82 times 2. Square root of that is equal to v. So that's is equal to 12.8 or 13 meters per second. Then at point D, it says the cart comes to a stop, and I want to know what is the height of the cart. So in a similar way we did before, I say KE plus PE at point A is equal just to the potential energy at point B, because up at here I just have potential energy. So that's 1/2 of m times 2 squared, just like we did before, plus m times g times 8 equals m times g times h. And I'm looking for h. The m's cancel out there, there, and there. That's 82 divided by 10 equals h, or 8.2 meters. That's the right answer there, 13. And just checking in here, notice that this height is higher than that height, as it should be. Consider this block is initially at rest. That means it only has potential energy. It goes down the inclined plane. As it goes down the inclined plane, it loses the work that is done by friction. And then at the bottom, it only has kinetic energy. First, what is the energy that it loses? That energy is equal to F times D. I tell you here, the kinetic frictional force is just 3 newtons times the distance. This is a 3, 4, 5 triangle, so 5 meters. So it loses 15 joules of energy. Then I want to know the speed of the block. Know the speed of the block at the bottom of the inclined plane. So I would start and say the potential energy minus the work that's done by friction is going to equal to the kinetic energy at the bottom. That's going to be m times g times h. The mass is 10 kilograms. G is 10 meters per second squared, times h is 3 meters. That's this distance. Minus the force of friction is 3 newtons. Or I could just put in the 15 there. The distance over which that force acts. Be careful that you use the 4 meters. Some students will be inclined to use the 4 here, but the force actually does act over 5 meters. And then that's equal to 1/2 of the mass, which is 10 times v squared. And I solved this. That's 300 minus 15 divided by 5. Square root of that is equal to v. That's what, 285 over 5. Which is 57. Square root of 57 is 7.5. That's it. 15 joules and 7.5 meters per second. Next, I want to know, I have this collision problem, and I want to know what type of collision this is. First of all, this is an inelastic collision. In an inelastic collision, only energy is conserved, no momentum is conserved. B, what is the total momentum of the system? Well, I can consider the initial condition and determine the total momentum of the system. I have the total momentum. Remember, momentum is equal to m times v. So that total momentum is going to be 1 kilogram times positive 4 meters per second plus 3 kilograms times negative 2 meters per second. Because it's to the right, or to the left, excuse me. That's 4 minus 6, so it's negative 2 kilogram meters per second. So this system has a net negative momentum. And then finally, I want to know what is the final velocity of the 3 kilogram mass. I set that initial momentum, negative 2 kilogram meters per second, uh, equal to the momentum in the final state, because I know that P initial is equal to P final. In the final state, I have two parts. It's going to be 1 kilogram times positive 2 meters per second. And then the last one is going to be plus 3 kilograms times V2F. And, just looking at it now, I know that that V2F is going to be negative because the first particle has a positive net momentum. So one better have a negative. So that's going to be negative 2 equals 2 plus 3 V2F, or negative 4/3 equals V2F. All right, that's it for the free response. Now let's do the multiple choice. Okay, this block has a mass of 5 kilograms and it's traveling with a velocity of 10 meters per second. And it encounters this rough spot where the coefficient of kinetic friction is 0.2. So mu is equal to 0.2 along that spot. And I want to know how far does it go. So all the kinetic energy that it has here minus the work that it encounters here will give me a net energy of 0. I need to know what is the frictional force first. Frictional force is equal to mu times the normal force. In this case, the normal force is just equal to the weight. So that's going to be 0.2 times 50 newtons. That's 5 kilograms times g. That's 10 newtons. So I start with a kinetic energy. I remove the work done by friction, and that's equal to 0 because it stops completely. That's going to be 1/2 mv squared minus F times D equals 0. And I'm looking here for D. Mass is 5 times V, which is 10 squared, minus 10 newtons times D equals 0. It's 250. Solve that for D, I get 25. What height would you have to drop a ball for its velocity to be 10 meters per second when it hits the ground? I want to know what is this height, so that at the bottom, V is equal to 10 meters per second. So this is a simple set. My gravitational potential energy up here equal to the kinetic energy on the bottom. M's cancel. I want to know the height. Height is equal to V squared over 2G, which is going to be 10 squared over 2 times 10. That cancels with that and leaves me with a height of 5 meters. But keeping proper sig figs, 3 sig figs, 5.00. This cheerleader is thrown to a maximum height of 6 meters. What is her speed when she goes through the basketball hoop at a height of 3 meters? So up here, she has potential energy, and here she has kinetic energy plus potential energy. I'm going to set those two equal. This is at the hoop. This is at the top. M times G times 6 meters equals 1/2 mv squared. I want to know V plus M times G times 3 meters. Those masses go away. That's 60 right here, 30 right here, so 60 minus 30 divided by 1/2, and then square root of that, that's the square root of 60. I get 7.7. A for number 3. Which of these have the same units as energy? This is potential energy. Yeah. This is kinetic energy. Yeah. This is work. And then this is elastic potential energy. So E is the right answer. What type of energy does this object have at point C? Well, at point C, it has both a height and a velocity. So it has both. 2 kilogram block is set on a spring. Spring constant, K, is 20 newtons per meter. And the spring is compressed by a distance or displacement of 0.5 meters. What is the maximum height? So it releases this thing and it goes up to some height. I want to know what is that height. So here I'm setting my elastic potential energy 1/2 kx squared equal to, excuse me, not kinetic energy, but I'm setting it equal to gravitational potential energy, mgh. So I'm solving this for h. I'm going to put some numbers in. 1/2 of 20 times 0.5 squared equals 2 times 10 times h. This 20 cancels with that 20. Half of a quarter is 1/8. That's equal to h. And that's equal to 0.13 meters. So it goes up about 13 centimeters. Here, what is the force acting on the block? Well, F by Hooke's law is just K times X. K was 20 times X, which was 0.5. So C for number 7. All right, so what happens to the various types of energy as it goes up? So as this thing goes up, what happens to those energies? Well, the gravitational potential energy, which is equal to mgh, that'll increase. So I can get rid of these. This one doesn't leave the other 3. The elastic potential energy, which is equal to 1/2 kx squared. The amount of compression is getting smaller, so that's going to decrease. So that gets rid of that one. And that one. So it's either A or D. And then finally, the kinetic energy, which is equal to 1/2 mv squared, it slows down, so that means that's going to decrease. So it looks like D is the right answer for number 8. Drop a rock off a cliff. What can you say about the work done by the gravitational force? Well, the displacement is in that direction, and the force due to weight is also in that direction, so that is positive work. The box slides towards you and friction acts on it until it stops. The force weight of the box does negative work. No, it actually does 0 work because it has no vertical displacement. Friction in this case does positive work. No, it's taking energy away, so it does negative work. The distance is not dependent on the mass. That's not true because the frictional force is dependent on the normal force, which is dependent upon the mass. So that's not true either. And then the velocity of the box is constant. But it says it slows down, so no. So E is the right answer. All right, so here's a block. I have all the forces drawn on this block, and I have a couple of questions I ask you about it. First of all, what is the work done by the force F? That's this force. Work is Fd cosine theta. That's 4 times the distance, which is 2. 4 times 2 times the cosine of that angle, cosine of 30. And that's equal to 6.9 joules. Then, what is the total work being done on the block by all of the forces? So the only other force, there's a component of the force doing work in this direction, and that work that it does is 6.9 joules. And then this force is also doing work, and the work that it does, which is F times D, is going to be -4 joules. So the total work would be 6.9 minus 4, which is equal to 2.9 joules. So E is the right answer. And then what is the total work being done on the block by the normal force? Well, that would be 0 because the displacement is horizontal, but the normal force is perpendicular. So theta would be equal to 90 degrees. And if I did work equals FD cosine theta, that would tell me his work is 0. All right. Billiard balls have a mass of about 0.2 kilograms. You hit the cue ball and you give it a speed of about 2 meters per second, and it collides with another stationary billiard ball. Hey, let's just draw this. I have a billiard ball, 2 meters per second, and another one is stationary, and then the cue ball bounces back at 1 meter per second, and I want to know now what is the speed of this ball. And they all have a mass of 0.2 kilograms. So I would say 0.2 times 2. That's the momentum of this first, the initial state. And then that's equal to zero point 0.2 times -1, that's this one, plus zero point 0.2 times v. Well, the zero point 0.2's all cancel. I just get rid of that. Oh yeah, that's kind of nice. So I have 2 equals -1 plus v. So v is equal to 3 meters per second. And it is positive, as we would expect it to be. So it's going to be D, number 14. This is straight from the concept test. So I have 10 meters per second here, and they stick together, and I want to know what this velocity is. Well, if you remember, it was half. The mass increases by 2, and so the velocity is going to decrease by 2. But I can do, my initial momentum is m times 10 meters per second, m times v, and then my final is 2m times vf. The m's cancel, so vf equals 5. This also was straight from the concept test. I have an initial momentum of 0 because it's sitting there on a stationary cart. And the final momentum is also going to equal to 0. So I can say that 0, the initial momentum, is going to be equal to the final momentum, which is going to include 2 parts. That's the mass of the cannonball times its velocity plus the mass of the car times its velocity. So 0 equals, the mass of the cannonball is 10, the speed is -50, plus the mass of the car, which is 1,000, times its speed. And that's what I want to know. So that tells me, when I solve that, I get V equals 0.5, positive 0.5, so B is the right answer. This car is going to move at 0.5 meters per second. You have a force acts on a mass over a time of 4 seconds. Let's just write down what we know. F is equal to 4, m is equal to 2, t is equal to 4. Its initial speed, v initial, is equal to 8 in the same direction as the force, so it's positive. We'll say the force is positive. I want to know what is its final speed. Remember, F is equal to delta P over delta T, which is a m delta V over T. Here I have 4 is equal to the mass, which is 2 kilograms, times V final minus V initial, which was 8, divided by the time interval, which is 4. And then I solve that. So I have 16 equals 2VF minus 16, or VF equals 16. So A is the right answer for 17. And then here, what is the impulse? Remember, impulse is just a change in momentum. So we could, now that we know this, we could, this is the m delta v, which is going to be 2 times 16 minus 8, or 16 kilogram meters per second. So B is the right answer for 18. But another way to do that is to say that F is equal to delta P over delta T. So delta P is just equal to F delta T. That's also the impulse. And F delta T, well, I know the force and I know the time, so it's also equal to 16 kilogram meters per second. All right. Softball hits you on the thigh. Ouch. Which of these affects the force that the softball imparts to you? The initial velocity of the ball, sure. How fast it's going. The velocity that it bounces off of you, yes. Remember, if it bounces off at a faster rate, it imparts more momentum to you. And then the mass of the ball is also important. Remember, F is equal to m delta V over delta T. So all of those things. It turns out the time that it takes to is important. Open cart rolls along a frictionless cart while it's raining. As it rolls, what happens to the speed? Again, this is straight from the concept test. That as this thing rolls along and rain falls into it, the mass goes up. Now momentum remains the same. So momentum is constant. So no outside forces acting on it. Um, so since momentum is equal to m times v, if this goes up, that must go down. So C is the right answer.